Have you ever wondered if we could travel faster than light? Light, this enigmatic wave particle, travels at a mind-boggling speed of approximately 186,000 miles per second. This impressive velocity is not just a number. It's a cornerstone in the grand edifice of physics, considered the universal speed limit. No object with mass, as we understand it today, can reach or exceed this cosmic speed barrier. This speed limit, however, is not just a rule. It's a challenge. Surpassing it could open doors to realms once considered purely the stuff of science fiction. We're talking about possibilities like time travel and interstellar exploration, venturing to distant galaxies that are millions of light years away in the blink of an eye. But is faster-than-light travel merely a pipe dream, or could it be a future reality? Let's explore 5 theories that suggest it might be possible. First on our list is the concept of warp drives. Now, this idea might ring a bell if you're familiar with the voyages of the Starship Enterprise in Star Trek. But what exactly is a warp drive? In essence, it's a hypothetical propulsion system that manipulates the fabric of space-time, sort of like scrunching a carpet so the spacecraft can leap across vast distances in an instant. It's like moving faster than light, but without actually breaking any laws of physics. Brilliant, right? But here's the rub. To bend space-time, we'd need something called exotic matter, stuff with negative energy density, which as far as we know, doesn't exist naturally. That's a pretty big hurdle to overcome. But despite these challenges, the idea of warp drives continues to captivate us. It's a tantalizing possibility, one that keeps the dream of faster-than-light travel alive and kicking. Despite the hurdles, warp drives remain a tantalizing possibility. Next up is the theory of wormholes. Imagine if you could fold a piece of paper in half and poke a hole through it to create a shortcut. That's essentially what a wormhole is, but instead of paper, it's the fabric of space-time. These theoretical tunnels could, in theory, allow us to bypass the cosmic speed limit, granting us faster-than-light travel. Wormholes are a fascinating concept, but they remain a mystery. We've yet to find any concrete evidence of their existence. Even if they do exist, we don't currently have the technology or understanding to create or control them. It's also worth noting that wormholes, as they're currently understood, would be highly unstable. They could collapse in the blink of an eye. However, some scientists believe that with the right kind of exotic matter, we might be able to keep them open. Wormholes may be elusive, but they could be our ticket to the stars. Our third theory takes us into the realm of quantum physics with quantum tunneling. Imagine a marble at the bottom of a bowl. In our everyday world, the marble needs a push to get over the rim. In the quantum world, however, the marble could just appear on the other side. This is quantum tunneling, particles bypassing barriers that, according to classical physics, should be impenetrable. Now, how does this relate to faster-than-light travel? Well, if particles can leap through barriers, perhaps they could also leap across space, effectively moving faster than light. Intriguing, isn't it? However, there are challenges. One key hurdle is scalability. Quantum tunneling is observed at the scale of particles. Can this phenomenon be scaled up to something as large as a spacecraft? This is a question that scientists are still grappling with. Quantum tunneling might seem far-fetched, but in the quantum world, anything is possible. Fourth on our list are the elusive tachyons. Now, tachyons are not your everyday particles. They're purely theoretical, and they're said to always move faster than light. Yes, you heard that right. Always faster than light. Imagine the possibilities if they were proven to exist. We could potentially unlock new methods for faster-than-light communication, or even travel. Imagine sending a message to Mars, and it arrives before you've even finished typing it. Now that's what we call instant messaging. But alas, theory and reality often diverge. The main challenge lies in detecting these elusive particles. Despite numerous attempts, no definitive proof of their existence has been found. Yet, the search continues. Science is a relentless pursuit, and the discovery of tachyons could be a game-changer in our understanding of the universe and the speed of light. Tachyons may only be theoretical, but their implications are fascinating. Finally, let's discuss the Alcubierre drive. Named after the brilliant physicist Miguel Alcubierre, this theoretical warp drive proposes a fascinating approach to faster-than-light travel. It doesn't move the ship itself, but instead manipulates the fabric of space-time around it. Picture it like this. The drive expands space-time behind the ship and contracts it in front, creating a kind of wave that the ship rides to its destination. It's like surfing on a cosmic wave, only the surfboard is your spaceship, and the wave is the universe itself. However, this concept isn't without its obstacles. One of the main challenges is the need for a form of negative energy, a concept that, while theoretically possible, we haven't been able to produce or observe in a lab yet. Despite these hurdles, the Alcubierre drive may be the closest we've come to a practical, faster-than-light travel method. All these theories give us hope for a future where faster-than-light travel becomes a reality. Let's recap. Warp drives could potentially bend space-time, making vast distances traversable in the blink of an eye. Wormholes, on the other hand, could provide us with shortcuts through space-time, effectively bypassing the speed of light limit. Quantum tunneling could allow for instantaneous transfers of information across vast distances. Tachyons, hypothetical particles that always move faster than light, could provide a theoretical framework for exceeding light speed. Lastly, the Alcubierre drive, a theoretical warp drive, could make interstellar travel possible by bending space-time around a spacecraft. Ongoing research in the field of faster-than-light travel continues to push the boundaries of our understanding. It's crucial to keep an open mind about these possibilities. The theories we've discussed today are just the tip of the iceberg. There's a whole universe of possibilities out there. While we may not be hopping across galaxies just yet, who knows what the future holds? Remember, in the realm of science, nothing is impossible.